11 physics students. I'm trying to give you like an example on how to calculate the position versus time graph. On the position versus time graph, the displacement between two different times. So in this one here, I have a position versus time graph of a certain motion or movement. And then I need to find the displacement between 8 seconds here and 24 seconds. Okay, so the first thing I need to know is that all the data that I have are only on this red line. So whatever I want to work with has to be on this red line or red graph. So if we need to determine that my initial time is 8 seconds, so how do I find the data on the graph that correspond to 8 seconds? So what I usually do, let me put this, I have my tools here. So I take, for example, a line and I go vertical from 8 until it touches the graph, and that will be my point on the graph here exactly. So that is my initial starting point at 8 seconds. Okay, and then we end at 24 seconds. So this is 24 seconds. So I need also to find the point on the graph that corresponds to 24 seconds. So I do the same thing here. So I come down vertical, and that would be that point here exactly would be the final, the point for the final data that I need to collect. Alright, so this point here on the graph has an next 8, or time if you want to say 8 seconds, but what is the position for it? So what is the y for it? For that, I also have to extrapolate or take a perpendicular, go perpendicular to the y-axis until it hits the y-axis, and then I read this data here. Okay, so when I do this, so for the initial position that I have here, the time is 8 seconds, and then the position is 12. So let me just mark it here. Let me mark it. Okay. So for this particular data, for this particular point, the initial point that I'm calculating, I will have that done. So initially, when I start at 8 seconds here, the position was actually 12 meters. Okay? So now the final position is here at 24 seconds. So let me bring my data here and say exactly where is that. So at 24 seconds, this is the point that I need to extrapolate to the y-axis, and it touches it here. So that will be my final position. Okay, so that data point here has x equal 24 seconds and then y equal minus 6 meters. Alright, so let me put the values here. So when the initial time is 8 seconds here, then the position or the initial position is 12 meters, 12 here. And then I go here, when the final time is 24 seconds, then the final position is minus 6 meters. Okay, so the displacement is final position minus initial position, so I would put the minus 6 meter minus 12 meters equal, okay, minus 18 meters. So this is the displacement. Final position minus initial position. So that means that the person starts here initially and then moved all the way to minus 6. After I got my data on the y-axis, I don't care at all about the other stuff anymore. I just look at these two data points, the blue ones. So if I want to just plot the movement between these two, between 8 and 24 seconds, will be like this, like the person moved from 12 meters to minus 6 meters. So that's minus 18 meters. So if I like cut this, if I take screenshot of this and cut it and paste it and turn it around, for example, something like this. If I take a screenshot of that, okay, and then if I paste it, so big, I can always shrink it, okay, and then can move it here. So this is the same thing, and then if I turn it around, okay, let's see, and then if I rotate that exactly, it would look exactly like this. Alright, so I just arrange it and I rotate it, it would look like that. So it is from 12 to 0 is 12 units, and then another 6 units, that will be 18 units in the negative direction. So it's exactly like this if you're going backward. So if you assume this is a positive, this is negative. So this data and the units here, if you count the units as a number line, are the same thing. Okay, I hope this helps. Thank you.